Sweating, breathing, wearing clothes, human biology constantly produces organic byproducts. When bacteria break those down, the resulting odors, from body odor to halitosis to sour textiles, trigger an immediate, hardwired response in the human brain. We are instinctively built to be repelled by them. When a deodorant stick advertises 100-hour protection, or a detergent claims to eliminate trapped smells, that is a regulated metric requiring hard scientific proof. But determining whether a product actually neutralizes a smell presents a unique technological problem. For decades, the standard approach relied on hardware. Instruments like gas chromographs sample ambient air and break down exactly which chemical compounds are present. But hardware has physical limits. Metal oxide sensors struggle to function in high humidity environments. They routinely fail to operate accurately in the exact places they are needed most, like the human underarm. This chart shows the relationship between chemical concentrations and a metric called hedonic tone. The data points scatter widely because knowing the physical amount of a volatile compound doesn't tell you how a person will react to it. Machines can detect sulfur, but they completely lack the biological capacity to measure disgust. Because sensors cannot feel repulsion, they cannot prove a product actually works. The only legally defensible scientific instrument capable of measuring an odor is a calibrated human being. The internet often circulates rumors about people whose job is to sniff armpits, framing it as a bizarre, casual gig. In reality, sensory evaluation is a rigorous clinical profession governed by strict international protocols, specifically ISO 8586. Before anyone gets hired, they undergo severe biological screening. The first stage is impairment testing, ruling out baseline olfactory deficits like anosmia. Those who pass move on to sensory acuity testing. Candidates are handed blind samples and must successfully match and identify specific, isolated environmental odorants without any visual clues. The final barrier is cognitive. A candidate must possess the capacity to attach precise vocabulary to what they are experiencing. They have to verbally differentiate complex sensory characteristics, clearly separating a note of camphor from the smell of rancid butter. This three-stage process eliminates the vast majority of the general public. The individuals left standing possess an elite, quantifiable biological sensitivity. Having a sharp nose is only the baseline requirement. These selected judges then undergo grueling ASTM training protocols designed specifically to overwrite their personal preferences and biological biases. They are taught specific physical mechanics. Instead of taking a deep breath, judges use short, rapid inhalations. This maximizes the interaction between the chemical volatiles and the olfactory endothelium without triggering adaptation, the biological reflex where your nose gets used to a smell and tunes it out. This diagram illustrates the scale calibration process. To ensure every judge scores a smell identically, their internal baseline is anchored to exact aqueous dilutions of a chemical called N-butanol, mapped out in parts per million. A judge must learn to completely separate two distinct variables. They score the sheer physical intensity of a smell on one axis, entirely independent of its hedonic tone, the measure of pleasantness or unpleasantness on a scale from -10 to +10. By drilling these standards repeatedly, the training overrides the brain's natural instinct to recoil from a bad smell. It converts a highly emotional sensory organ into an objective data collection tool. With the human instrument calibrated, the testing environment must be equally controlled. ISO 8589 testing facilities consist of isolated booths and preparation rooms designed to be perfectly sterile, odorless, and free of physical distractions. Inside these facilities, the clinical reality is deeply uncomfortable. To test a deodorant's efficacy, human subjects are placed inside tightly controlled, temperature-regulated hot rooms to induce a sweat response before the judges step in. Similar clinical rigidity applies to breath. For halitosis, judges use the Lows-the-Burp scale, grading severity from 0 to 5. The protocol requires the subject to close their lips for 3 minutes, then exhale through a tube precisely 10 centimeters from the judge's nose. To verify the human instrument remains accurate, these organoleptic assessments are frequently cross-referenced against gas chromatography readings, checking the judge's score against exact parts per billion measurements of volatile sulfur compounds. Every element of this process, from the hot rooms to the plastic tubes, isolates the variable of odor from environmental noise. Once the testing sessions conclude, the individual scores from an entire panel of judges are mathematically aggregated. Through statistical models like repeated measures ANOVA, highly subjective experiences are processed into hard, actionable data. That data carries massive economic weight. It is the final hurdle that determines whether a multi-million-dollar chemical formulation reaches consumer shelves or is scrapped entirely. Beyond consumer goods, this clinical sensory data has direct medical applications. Accurate halitosis measurements provide essential diagnostic evidence for dentists identifying bacterial infections and treating severe periodontitis. The role of an odor judge is far removed from online jokes. These are highly calibrated professionals executing a demanding, exacting service behind closed doors. Our modern expectations of hygiene and social confidence rely directly on this hidden workforce, people specifically trained to intimately analyze the exact odors the rest of society pays to hide.